Good day everyone. Today we will discuss part 3, the logarithmic and exponential functions, the differentiation of transcendental function in differential calculus. After the completion of this module, students should be able to interpret and solve the differentiation of logarithmic functions and define and solve the differentiation of exponential functions. Let's discuss properties of logarithms. Number 1, this is a product rule. Log a x times y is equals to log a x plus log a y. Second, this is quotient rule. Log a x over y is equals to log a x minus log a y. Third is power rule. Log a x raised to n is equals to n log ax. Number 4, log a times a raised to x is equals to x log a times a is equals to x. And last, a raised to log a times x is equals to x. We have some example here. Sample number 1, log 10x is equals to 4. So we have a basic formula here. 10 is the base, 4 is the exponent. Thus, x is equals to 10 raised to 4th or equals to 10,000. Example letter B, log 4x is equals to 3 halves. So same problem, the base is 4 and the exponent is n. Then x is equals to 4 raised to 3 halves or equals to 8. Okay. Sample number 3, log 10x is equals to negative 2. So say we have base here is 10, exponent is negative 2. So those, x is equals to 10 raised to negative 2 or equals to 1 over 10 squared. So the negative sign here means it will be transferred into the divisor. So our final answer is equals to x is equals to 0.01. Sample number 2, ln x is equals to ln 2 plus ln 3 plus ln 5. So from our given, you can use the formula number 1. So this is a product rule, equals to ln 2 times 3 times 5 is equals to ln 30. Then we have to reduce the equation. X now is equals to 30. Example number 3, ln x is equals to 2 ln 3 plus 3 ln squared minus ln 1. So here we can use two formula, the product rule and the quotient rule because of the negative sign. And there is the plus sign. So continue. ln 3 squared plus ln 2 cubed minus all ln 1. So here the 2 value is moving to the power. The 3 here is also moved here. Thus, ln is equals to 3 squared times x squared. So this is the product rule over 1. So ln 1 is in quotient rule. Then ln 9 times 8. So this is equals to ln x equals to ln 72. Then again you have to reduce the equation. X now is equals to 72. Next topic is the differentiation of logarithmic functions. The following formulas provide the rules for finding the derivatives of logarithmic functions. In this formula, u is a function of x. Formula number 1, d over dx log du is equals to 1 over u log de du over dx. And formula number 2, d over dx and u is equals to 1 over u du over dx. Example number 1, find du over dx if u is equals to log 5, 4x plus 3. So here our given is in log form, so we'll use formula number 1. Then let u is equals to 4x plus 3, this one. Then dy over dx is equals to 1 over u, so our u here is 4x plus 3. Then log 5e d over dx times du, which is 4x plus 3. Then we'll have to differentiate this part. So d over dx, 4x plus 3 is equals to 4 times the log 5e over 4x plus 3. So our final answer is 4 times log 5e over 4x plus 3. Example number 2, find dy over dx if y is equals to ln times 5 minus 3x. So our problem is in ln form. We'll use formula number 2. Then let u is equals to 5 minus 3x. Then dy over dx is equals to 1 over u, which is 5 minus 3x, times d over dx times u, which is 5 minus 3x. Then we need to differentiate this part. D over dx times 5 minus 3x. So this will be negative 3 over 5 minus 3x here. So our final solution is equals to negative 3 over 5 minus 3x. Example number 3, find du over dt if u is equals to log a 3t minus t cubed. So here our u is 3t minus t cubed and it is in log form, so we'll use formula number 1. Then du over dt is equals to 1 over u, which is 3 minus t cubed, log a e times d over dx times u. So here we have to differentiate this part. So here we can differentiate here 3t minus t cubed is equals to 3 minus 3 using power rule, 3t squared. So this equals to 3 times 1 minus t squared. Those are for answer. Final answer is 3 times 1 minus t squared log ae over 3t minus t cubed. Example number 4, find du over dx if u is equals to ln a squared minus x squared raised to 3 over 2. So our problem is in ln form, so we'll use formula number 2. Then our u here is equals to a squared minus x squared raised to 3 over 2. Then du over dx is equals to 1, so we'll use the ln form. 1 over u, so our u is a squared minus x squared raised to 3 over 2 times d over dx times u. So our u here is a squared minus x squared raised to 3 over 2. Then we have to differentiate this part. So again, this is also a power rule. So 3 over 2 times a squared minus x squared. Then 3 over 2 minus 1, so equals to 1/2. here. Then you have to put it here, and the du is negative 2x. Here we'll continue. So x squared is negative 2x here. So our final answer now will be negative 3x over a squared minus x squared. Our next topic is differentiation of exponential functions. The following formulas provide the rules for finding the derivatives of exponential functions. In these formulas, u is a function of x. Formula number 1, d over dx, a raised to u is equals to a raised to u times ln a times du over dx. Formula number 2, d over dx, e raised to u equals to e raised to u times du over dx. Example number 1, find dy over dx if y equals to 4 raised to 2x. So from our problem, this is the applicable formula is formula number 1, au. So where our u is equals to 2x. Then dy over dx is equals to 4 2x times ln a. So ln a is 4, ln 4 times du over dx. So our differentiation of 2x is 2. Then 2x equals to 2 ln 4, and our final answer here is equals to 4 squared ln 16. So 2 ln 4 is equals to 4 squared ln 4 squared. So 4 squared is equals to 16. This is our final answer. Example number 2. Find dy over dx if y is equals to e over raised to sine x. So here the problem is in e form. So we'll use formula number 2. Then our u here is sine x. Then dy over dx is equals to e sine x. Then the differentiation of our u sine x is equals to cosine x. Those e raised to sine x times cosine x. So this is our final answer. Sample number 3. Find dx over dt if x is equals to t squared times e raised to 2t. So our u here is 2t. Then the problem is in e form. So we'll use formula number 2. Then dx over dt. So we have to apply the power rule differentiation. So first is we have to copy this one, t squared. Then the d over dx of this one. So 8 2t times 2 plus, then we have to copy this one, e raised to 2t times the differentiation of t squared, which is equals to 2t. Those 2t e raised to 2t times t plus 1. Then our final answer is equals to 2t e raised to 2t times t plus 1. For example number 4, find dv over dy if y is equals to 4 tangent y. So from our problem, the given is in a raised to u, where our u is in tangent y. Next, dv over dy equals to 4 tangent. We'll use this formula number 1. A is 4 tangent yu is tangent y. Then ln a, so ln 4 times the differentiation of tangent y is equals to secant squared y. Then our final answer is 4 tangent y times secant squared y times ln 4.